According to an article published by Nightview Capital on August 15th, 2024, global smartphone ownership rose from around 12% in 2014 to over 60% by 2024. This surge is no coincidence. The rapid growth of the internet and the widespread adoption of smartphones are closely linked. Smartphones have made the internet more accessible, portable, and user-friendly, connecting millions of people who might otherwise have remained offline. As we watch this curve climb, take note. For each year on the horizontal axis, there is exactly one corresponding smartphone adoption percentage on the vertical axis. This pairing of year to adoption percentage forms a relation, and in this case, it behaves like a function. In this video, we'll explore what it means for a relation to be a function, and how to determine whether a given relation represents a function. By the end of this video, learners will be able to determine whether a relation represents a function. A relation is simply a set of ordered pairs, written open parenthesis, x, y, close parenthesis. The set of all x values is called the domain, and the set of all y values is called the range. Let's consider this example of global smartphone adoption by year. Here, x represents the year, and y represents the smartphone adoption percentage. Note that each value in the domain is also known as an input value or independent variable, and each value in the range is also known as an output value or dependent variable. In this relation, each year is paired with exactly one percentage. This is a key feature of a function. Next, when does a relation qualify as a function? A relation becomes a function when each input in the domain pairs with exactly one output in the range. In other words, no input is paired with more than one output. In our smartphone example, each year in the domain is paired with exactly one adoption percentage from the range, so this relation is a function. But what if we had two entries for 2019, like 29% and 31%? Now the input, 2019, corresponds to two different values in the range. This violates the definition of a function, so the relation is not a function. Now that you understand what relations and functions are, let's explore different representations and real-world scenarios. A restaurant menu lists different milkshake options along with their prices. Let's explore two important questions. A, is the price a function of the drink? B, is the drink a function of the price? Let's think about it step by step. First, let's consider the drinks as the input values and the prices as the output values. We notice that each drink has exactly one price. That means the price is a function of the drink. Now let's flip it. What if we treat the prices as inputs and the drinks as outputs? Well, suppose the blueberry and mango milkshakes both cost the same. That means a single price is linked to more than one drink. In this case, the drink is not a function of the price, because a function cannot assign the same input to multiple outputs. Next up, we have a report card where a student receives marks in different subjects. Each subject is assigned a specific mark. Let's explore two important questions. A, is the score a function of the subject? B, is the subject a function of the score? Let's think it through step by step. First, imagine the subjects as input values and the marks as output values. We see that each subject has exactly one mark assigned to it. That means the marks are a function of the subject. Now let's reverse the situation. What if we treat the marks as inputs and the subjects as outputs? In this case, both math and history have the same mark, 90. That means one input, 90, is paired with more than one subject. So the subject is not a function of the marks because a function cannot assign the same input to multiple outputs. Great job following along with today's lesson. Now, let's put your understanding to the test. Below are two sets of ordered pairs. 1. Is A a function of B? 2. Is B a function of A? Pause the video and figure out. Got it? Let's check your answer together. In example A, notice that the input 2 appears twice paired with different outputs, 5 and 8. That means one input has two outputs, so A is not a function. In example B, each input is paired with only one output, and no input is repeated. Therefore, B is a function. Wow, we covered a lot today. To sum it up, a function is a relation where each input has exactly one output. From milkshakes to report cards to ordered pairs, this rule holds. Thanks for watching, and don't forget to like, subscribe, and hit that notification bell so you won't miss out on more fun learning videos. See you next time.